Question 6. This one is coming from application of differentiation. Yes, connected rates of change. A curve is such that dy dx is equal to 6 out of 3x minus 2 brackets cubed, and a is 1 negative 3 lies on the curve. A point is moving along the curve, and at a, the y-coordinate of the point is increasing at the rate of 3 units per second. Find the rate of increase at a of the x-coordinate of the point. Now, they want us to find dx dt, okay? Dx dt, but we are given dy dt, the rate of change of y, which is equal to 3. And we are also given dy dx. Sometimes they just give you the equation of the curve and you're supposed to find the dy dx, okay? So this one is already given, 6 out of 3x minus 2 cubed. Now we are supposed to find dx dt, okay? Now at a, first of all, at a, which is 1, then negative 3, what will be the value of dy dx there? So this will be 6, then out of 3 times 1, that will be 3 minus 2. That one will give us a 1 cubed, is still a 1, so 6 over 1, that one will give us a 6. Now, how do we get dx dt? Here we use chain rule. What I will do, I will put dx, and then I put dt here. Now, x and y are connected, so I will say dx over here dy, then I say times, then I put dy here, such that it can cancel with this one. Now, dx dy is the same as saying 1 over dy dx, because this one just somersaults and then it goes up here to give you this one here. Then, after that, we are going to have this dy dt. Now, we have here 1, dy dx at a is 6 here. So I will put here a 6, then times dy dt, it is given as a 3. So 3 over 6, that one is a half. So that is that. But b, find the equation of the curve. Of course, here we are just going to integrate. So y will be equal to the integral of dy dx, okay, with respect to x. Now, y is equal to the integral. Remember, we have 6. We have it as 6 out of 2x minus 2, then this one, brackets cubed. Then I can take this one up, and then the power will be a negative. So I'll come back here and I write 3x minus 2, then power negative 3 with respect to x. And then when you're integrating, please don't bring back this integral sign. So I'll come to this one here. We increase the power by 1. We divide by the new power. And then we multiply by the derivative of this one here, which is a 3. And then from there, we add an arbitrary constant, because we don't know the constant that disappeared when they differentiated, okay? You should know that the integral of ax plus b to the power of n with respect to x is going to be equal to ax plus b. First of all, this one is got from differentiation, and we use the chain rule, okay? So we enter inside here and we differentiate here, then we divide it through. So that is how it comes here, and then multiplies with that plus c. So this is what we are applying, okay? That is what we are applying here. Now y is going to be equal to, this one will give us a negative 2 times 3, that will be a negative 6. So meaning it will cancel with this one here, and the whole thing will become a negative, all right? And then this is a negative 2, so I can take it down, and it will be negative 1 out of, then 3x minus 2, then to the power of 2, now plus c. Now, for us to get the value of c, we need to use a point that lies on the curve, and it was given here already. Point A is on the curve, so that is 1, negative 3. So I will come back here, and I will say this is point A, which is actually 1, negative 3. So the y coordinate is a negative 3, and then the x coordinate is a 1. 3 times 1, that is a 3 minus 2, that will be a 1 squared, that will still be a 1. So meaning here I have negative 3, which is equal to negative 1 here, plus c. So negative 3, then plus the 1 when this one crosses, and then this one is equal to c. So c is going to be equal to negative 2. So meaning the equation of the curve is therefore going to be y equal to negative 1 out of 3x minus 2 squared, then minus 2 here. That is that.